Good evening. Good evening. All right. It's already session number 7 for my little project here, which you see there on the screen. For those who are here the first time, let me quickly introduce the project. Also myself, maybe. So first the project, important bits first. I am working on a digital dashboard to show various data sources, visualize them, data sources that I found I regularly check, often in the morning, but also during the day, and where I recognize that, hey, I have to use different applications, I have to navigate to different websites and navigate the menu there. Just to get that information, why not gather, aggregate all that information and show it on one screen, bring it all together. And not only is this meant to be an exercise to learn more about Azure and what Azure offers, it's also, even more than the convenience aspects of it, it's really meant for me to get information like, okay, I can see that currently my solar installation is producing a lot of energy. I could use that to charge up the car, the electric vehicle. So things like that should be collected here. And if you're interested in how we got to the point where we currently are, which is this aggregate function that we're working on here, Azure function, then check out the repository. I put that on the chat window. I should probably copy that again and paste it here. This is where you find the source code, and there you find also links to a YouTube playlist where all the previous sessions have been recorded. All right, so who am I then? My name is Rene. Thanks for joining if you're watching. And I work for Microsoft, but really in my spare time, I try to use the technologies that we build, that we sell to our customers. And I'm doing that to learn more about specific technologies, how to bring technologies together. And here I want to bring together things like Docker, Azure Functions, Azure Durable Functions, Azure Tables or Azure Storage Tables, Azure Blob Storage, static file hosting, etc. We'll see where the journey is going to take us. The project, as always, it's progressing a lot slower than I expected it. And yep, with that, I'm jumping over to Visual Studio, and I want to continue where I stopped last week. So if you were there last week, chances are actually pretty low that you were there last week, because I'm trying to play a bit with the times with my schedule here. So I usually do this stream in the morning, my morning, and the consequence was that there were very few attendees. So I thought, let's start pushing this towards my afternoon and now into the evening. Just hoping to get a bigger audience, maybe than folks from the States, or just from different time zones have a chance to join here. And apparently, looking at the viewers, it seems to be working. All right, so end of last episode, I was struggling a bit with a variation of Azure functions, and those were Azure Durable Functions. Let me see, here we've got a new tab. If we Durable can bring up a little bit of info, what those things are. Functions overview, there they are. So Azure Functions, they are meant for creating a server or live in a completely serverless environment. It's called function as a service. And what you can do with this is you just have a piece of code and you execute that, well, on the internet without having to worry about a virtual machine or even some sort of web service that you have to maintain. And if we look at the functions that we have in the project so far, there's, let's just pick that one, source solar. So this is the function that retrieves the information about my solar installation. That function is really just one run method. And in that run method, I'm calling a little helper library, which does the actual HTTP calls to retrieve that data. And what that function does is it returns everything as JSON. That's really all it does. So the whole thing is what? 68 lines of code. And I can deploy that to Azure, and I'm going to end up with an IP address. And then I go this IP address /API, and in this case /getSolar, and it would run that code. And I would only pay for the minutes or the seconds that this code is actually executing. So I don't have to pay for a virtual machine. I don't have to worry about the hosting environment. I just get this piece of code onto the internet. And whenever I run it, I pay for it. It's really pennies that we're paying here. Now, the concept of functions means that they are limited with regards to the execution time, and they are by definition stateless. I mean, if we think about it, if we pay for every second that they are executing, if they were stateful, then they'd be up and running all the time, and then we'd be better off running a virtual machine. So what is now new with Azure, or relatively new, is the concept of durable functions. So durable functions are an extension of regular functions, and they can be useful if you have things that run longer and that orchestrate other functions. And a great example here in my case is, I want to go ahead, look at the diagram here. I want to go ahead and have one function. That function is meant to be triggered, I don't know, every 10 minutes or something. And then this function checks which other functions should it call, or I could say which other sources should it pull. And if it finds that, okay, it's time to get information about the solar installation source, it will do just that. But at the same time, it might call the source that returns information about the state of charge of the electric vehicle. So it calls out, it fans out to other functions, and it waits for all of them to complete and then processes the results. Last episode, I was struggling a bit with, well, how would I actually do that? And I think I figured it out. So that's exactly where I want to continue. So I ended the session with promising that I'm gonna read a bit more about this. And I recognize now that it's not exactly rocket science. So it's actually pretty simple even. But isn't it always simple if you know what you're doing? Anyway, so let's go ahead and create a new function here in the project. We want to go add a new Azure function. And I want to see what we have here, an Azure function, and this is going to be my aggregator. So this is eventually going to be something that is timer triggered. For now, we're going to make it HTTP triggered. And I got to move the windows a bit out of the way here. Whoops, wrong one. Yeah, great. Now I closed the wrong one. There we have it. So we want to go with an HTTP trigger, but really there should be, there it is, durable functions orchestration. That's what I'm really after here. Go ahead and do that. And let it create that. It's going to create some sample code here that we can use as a starting point. We have it, so I named the function aggregator, and we can call this function just like any other function. In fact, if I don't do anything here, I'm just going to run the project. It's going to fire up the Azure Functions runtime, which is exactly the same runtime that we would also find when deploying this project into the Azure cloud. That's something that is actually super cool about this, that you have exactly the same behavior locally here. So whether you're on the Mac or on Windows, or run this actually in the cloud, rest assured that it's behaving exactly the same, because it's not an emulator or something like that. It is the actual runtime. So I want to, and if it completely fails here and crashes, then it will also fail on Azure. Let's run this, and it should find our new function in there. There it is. So there we see it. We've got here the individual sources, and there's our aggregator function. And if I copy that, I should be able to call this with Postman, for example. Let's just do that. Add something new here. Have it, paste that, and just see what happens. It's doing something here in the background, starting orchestration, whatnot. And what we get back here is some JSON that is not the ultimate result. Because what it's doing, this is orchestrating other functions. It's now reaching out, it's running code that doesn't complete individually, that doesn't complete immediately, but instead it waits for all the calls to complete. Now here's the thing. If these calls, let's say they take 1 minute each, it's not that it sits there for 3 minutes and I have to pay for the full 3 minutes that it's waiting. Instead, it just says, okay, I'm firing these off, and then I'm going to sleep. And only when the calls return, that's when it's going to pick up execution of that durable function, and it can process the results. And that's when I have to pay for execution time again, which is of course super smart. So I can have something long running, but still don't pay for the waiting. Let me remove that timer. So what we get back is a status query get URI, and I can take this here hopefully. Let me see if I can mark this. So we get back a specific URI here, and we run this. And if I execute this now, it should give me the aggregated results. So what we get back here from this function is these three. This output of strings, hello Tokyo, hello Seattle, hello London. So what it did here is it called 3 individual functions, each taking a bit. One says hello Tokyo, the other one hello Seattle, the third hello London. And only after all 3 of those become available, the result of this orchestrator becomes available. So in the last module, I got kind of stuck here and I was like, all right, how would I call my sources? And here's what I discovered. And it's not super hard. First, we got to understand where does this execution start, and it starts in here. The function name is aggregator HTTP start. And I can of course rename that, and I think I'm gonna do that. I'm gonna call that oops, no changes are not allowed, because eventually this is not going to be an HTTP start. This will be timer triggered. So aggregator, I'm just going to call it aggregator start. HTTP start, well, it doesn't have to be HTTP start. The method name here it doesn't mean anything really. For now, we keep it an HTTP trigger so we can test it. We don't need post here, just we get this starter and so on. So here's what we can do in there. We've got one thing to do. I'm going to mark this here so we don't forget. I first need to read information about what sources does my application actually support. In the last episode, I talked about creating a registry where I can dynamically add, remove sources. So we got to read that and find a way to do that. And then we gonna start a new asynchronous call here, and the string here that represents the function that we are executing. So if we look for aggregator in here, there it is. This is what it's running. This thing here that is called run orchestrator. So that's what we're calling. And so this immediately returns, but in here we can now do our long-running, perform our long-running executions. So now what I'm going to have in here is, of course, not a list of strings. Actually, let me comment that out. We want to call sources. And the way the data is passed here, it's all done via serialization. So remember, it's starting that function and then it's sleeping. And when it picks up execution, it has to deserialize all the data. So it's going to call that run orchestrator multiple times. Every time it's going to pick up execution. With that in mind, what we're going to need is, well, the sources that we are planning to poll. So these are going to be our registry entries. I need them in here. And a registry entry, I think I've got that over there. Where is it? There. A registry entry contains information about the URL that's going to call, how often it should call that, when was it last updated, and what is that source about? Is it about the charge state of the car? Is it the workout of the day? Is it the power that the solar installation delivers? Whatever. So that's what we're going to get here. And we can get this from the context that is passed to us here. So this context contains all the serialized data that we might be interested in. We can get some input. And this has to be a specific type that we're getting here. And we're going to get a list of things. We're going to have multiple of these sources. And we still have to define them. So for now, I'm just going to use object here. I don't think that will work, but I'm just going to keep it like that for now. I see it's not even complaining. So we need to define that type here. And once we have them, we could go ahead and start calling out to a function or to another method that then gets the information from the individual sources. And that's where I got stuck last time. I was like, how do I call another function? Well, it was right there. It's just call activity async. So here's what we're going to do. I'm going to iterate over our registry entries in there. And for weird formatting going on here. For each of them, we're going to do a context call activity async, and we have to specify what will be returned here. Again, I'm going to make that an object for now. That will be a different one though. And then we go for aggregator. What is it called? Aggregator. Give it a name. Read source. So that string is going to identify the piece of code that it will run, and we pass that item that we just had here. We pass that as a parameter. It's an async method, so I could either await that, or what I'm doing here, I'm going to say I don't want to wait for this because I can fan out here. So if we, oops, where's our diagram? There it is. If I look at the diagram, I don't really have a problem with getting all the sources at once. Makes perfect sense in here. Why would I wait for it to retrieve the car source just to then get the information about the state of charge or the solar roof? So we can just fan out and call all of them. That's what we want to do. We just got to wait for all of them to complete. So let me add a little variable here that we're going to call tasks, and that's going to be a new list of tasks. I'm just going to add that in here. Task.add task. And then down here, we're going to await all of them. So if all of them have completed, we are done. And I wonder, can I specify a timeout here? Thought I could. Well, anyway. Then, so that's this one here. And well, then we can process them. We are going to iterate over all of them. Or maybe we do this afterwards. Let's first think about the data types. So this here is gonna go away. And we still have to think about our return values. So for now, what this returns, well, I don't know what this is going to return actually. It's probably just some status information. How many sources did it get? How many did succeed? I don't know. Does it return anything? We could just return. What are we going to return? You know what? For now, I'm just going to return a string. I'm just going to say, okay. I'm really creative here. I just wanted to build for now. Now let's worry about these types here, where we just have object right now. That obviously has to be fixed. So first of all, calling a source, that will return always the very same object. That's going to be a source DTO. We have that here. So source DTO, that defines what every source returns. And we have this here. A source DTO is eventually going to be a piece of JSON that contains the ID of the source and the individual data fields that it has. That's what we want here. That means this here is going to be a source DTO. So is that lowercase or uppercase? It's uppercase. Let's result that in a different namespace. Okay, so we need to build out this method there. I'm gonna just replace this here. So the aggregator hello becomes our aggregator read source. I'm gonna call that read source in here. And it's not returning a string, it is returning a source DTO. That's what we specified up there. And because this is going to be asynchronous, this is a public async static task source DTO. What is it complaining? Yeah, that's good. Our activity trigger, that's new in Azure Durable Functions. So if you have worked with Azure Functions, you're aware of HTTP trigger, of timer trigger. So this is a new one. It's an activity trigger. That means it is getting called from this orchestrator. Get access to the logger. We can probably log something here. Say reading source data 4, and then we need to use our registry entry, but we don't have that yet. But we're gonna have it in a second because we are passing that registry entry. Now we have it down there to that method. That's our parameter. Now this is our unknown object here. We gotta fix this. And well, let's just return some dummy information for now. Doesn't really hurt. We're gonna implement that later. So let's return a source DTO with some ID, and I'm just gonna use the registry entry, which eventually will have a name. We don't have defined that yet, but I suppose it's gonna contain that. So that's what we have to build. Now let's see if this method is complete here. Well, almost. It's still showing green squiggles here because we made it async, or I made it async. I'm guilty. And I wanna simulate a bit that calling these sources may take longer for some of them, or maybe fast for others. So let me just introduce a random delay here. So we simulate that behavior. That's going to be a new random, and I'm going to generate the delay. You see, I'm super verbose here with my code. Random.next, and we want to make this maybe between 2000 and 5000 milliseconds, something along these lines. We can then log information, and in our output, sleeping for delay milliseconds. Just simulating that here, and then we got our await task.delay delay. And eventually we're going to return something. Obviously that's going to be the result of that call that we don't have yet. So we need to add some HTTP client code in there. Okay, so what is now? Okay, this is unknown. So we need to define this. And I think we're going to have just create some object that represents a registry entry. So what that should be is defined over here, like probably a string identifier, or what I just called it name, that property. So we're gonna have a name in there. We're gonna have a URL in there. We're gonna have an interval in there. We're just gonna make that seconds delay, or interval in seconds, and a date time offset, UTC last update, something like that. Let's define that. That's gonna be a registry entry. gonna need this up here too. Registry entries is a list of registry entry. We're gonna pass that in there, and we have to define that. Let's go and do it. I need a public class registry entry. So what is that registry entry? If it lets me add it in here, there we go. I already figured it would have a name because I used that property. So let's add it so the compiler is happy. It's gonna have a URL. This is the URL where the source can be found. And the way I'm building this out is that currently all of the sources that I have, they are part of the actual project. So the source for the electric vehicle, for the solar installation, for the workout of the day, everything is part of that functions project. But it could well be that there are other sources somewhere else. So somebody decides, hey, Rene, great project. I want to set up a source that you can call. I'm going to give you the IP address or the URL, and I return that expected JSON format, and then we could use that in here. So it doesn't have to be running on the same server or even be part of that project. Let's go ahead and add that. Now, if you feel like, what are you talking about? This sounds like complete overkill. Correct. But the point is also that I want to learn about decoupled systems a bit, how to separate this, what would I do if this is picking up attention and people would like, hey, I want to have this digital dashboard, and suddenly I get like millions of hits on those sources. Now with functions, I could scale them up. I could scale them out. I could just say, well, run hundreds or thousands of instances of these. And that's why I'm building it that way, just to get a bit of practice here. So that's going to be last update UTC. Pro tip, always store date time in UTC or in a defined time zone. I still remember we were working on a big project, and eventually we expanded from Europe to the US, and suddenly we had a server up and running over in the US, and all the other data centers, they were located in Germany for Europe. And that server was obviously was configured with a different time zone, with different locale. And we noticed that some services, they suddenly don't run anymore, or they run way too often. Well, what was the reason? We didn't specify what time zone is our date time in. So if the German server was reading something, it interpreted as Berlin time, and if the US server was reading something, it interpreted as, I don't know, West Coast time or something. And big mess. Took a while to figure that out and fix it. So I always like to specify what we're talking about. This is going to be UTC. We're going to need a property that is our interval. Let's just do seconds here. This is how often should a specific source be called? Like every 10 minutes, every hour, every day, can all be represented in seconds. And I probably want something that allows me to enable or disable a source. So I don't want to remove it from my code in order to disable it and redeploy. I just want to go into the database and say, this source, please don't use it. It's currently down. It's non-functional or whatever. So that's going to be enabled. Is enabled? I like that better. Is enabled. And you know what? I'm a big fan of having a two-string override in these classes. Why? Simply because it helps when debugging to know what this object is and what's in there. You can see it immediately in preview. I just want to put everything in there that we have. So I want to know, what is that object type? I want to use name off here in case I refactor it ever. Registry entry. And that registry entry has got a name. I think I want to copy that. What's next? We're gonna have a URL. We're gonna have last updated UTC in there. There's a interval seconds, and there's an is enabled in there. Is enabled. Let's put that in there. Name is name, URL is URL. Last updated. Last update, not dated. Interval seconds. And that is enabled. And now the debugger is going to tell us what are we looking at here, if we need that. With that, we can go back if my mouse cursor is moving. I gotta check something because right before this session there was a hair from my cat in the mouse. Isn't it typically the other way around, that there's a mouse in the cat? Now there's a cat in the mouse. I think I got it. So working again. Aggregator down here. We've got our registry entry. It's gonna pass the registry entries that it gets from the context here into this aggregator read source method, which we have down there. It's gonna take a bit. And now we're back to our to-do where we read the registry. Now the plan for the registry is to have that inside a, where is it? Up here, inside a Azure Storage Table. But really for testing this out, we should now not depend on that table. So let's just mock something here. Let's go ahead and say we want just some registry entries. We're just going to create them. It's going to be a new list. New list of registry entry. And I'll just mock some of them. It's a new registry entry in there. Add a bunch of semicolons, make it happy. So this registry entry is, what are we gonna call it? That's the workout of the day, for example. And I think name is the only one that I'm using down here, so I don't have to specify anything else. Let's just throw in another one and the third one. So that would be solar, and this one here is EV, doesn't really matter. Those three are our registry entries, and then we're gonna start a new asynchronous call to that aggregator, and we want to pass in all the registry entries, but only those that are currently in. Yeah, I want to add that right now. So let's try this. I'm gonna add another one here. See if that's working, because we're gonna need that anyway. Name is disabled, because what I'm going to do here, I'm going to is enabled equals false, and for the others I'm going to set this to be true. So default value is false. I want to make sure to initialize this correctly. So down here I want to filter this and say only those where the registry entry is enabled. Come on, is enabled. Would be so much easier with auto-completion using system link. There we go. So here's what's happening now, and I think this is pretty interesting what's going on here. When I run this method via an HTTP trigger, which later is going to be a timer trigger, it's gonna read the registry entries. Well, right now I'm just mocking them. Then it's gonna perform this asynchronous call to the aggregator. we have it. All the way up. This one here. It will run that code and it will understand that, okay, I have to fan out here. I have to call this aggregator read source method multiple times. And they're going to return after a different delay. I don't know what that delay is. So the first await that it hits here, it just stops execution. It's going to bail out of that method. And when the first one here completes, it's going to pick up execution in here. And here's the thing now, it's going to run that orchestrator method again. And yes, it's going to run it from the very beginning. It just picks up right there until it hits the next await, or it hits the same await again. And it will remember, okay, I already awaited that, so I'm probably done by now, or I'm going to await the next. And to enable that, it's going to store all kind of information into a storage. So just like functions, durable functions need a storage account attached, where they can park all the information that is needed to pick up execution right where they left. So that's the trick, how they made this stateless environment somewhat stateful. A consequence is that what you have in here must be 100% repeatable. So it must generate exactly the same result every time. That's why I'm not reading the registry entries in there, because it could be that when the first time this runs, one of the sources is enabled, and the next time this runs, something changed in the database, then two sources are enabled. That would yield a different result, and that would probably bring it down, or the result would be incorrect in the end. So whenever you get here, it should be predefined, or it should be the same input parameters. That's why we're reading them down there when we kick off the execution. When this is called multiple times, it's always going to be the same serialized context that we have there. If you want to learn more about this, there's plenty of good blog posts out there. There's documentation at docs.microsoft.com about durable functions. There's, I think, where did I find that? Yeah, there's on YouTube. There's Azure Friday with Scott Hanselman, where you can learn about those. So more about the details. Now let me see if this builds. It's always that moment, right? I keep on talking. I should just hit the build button. Build succeeded. It's running it. So what I hope to see now is that it's going to execute this aggregator if I call it. And then if I look at this status URL that I'm getting back, I should see that for a bit it is not complete, and then eventually I should get my, how many are there? 3 sources or whatever I defined. So here it is, aggregator start, that's the one we want. To Postman, this one here, send this. And it returns, and it's giving me this URL here, and I'm trying to be fast enough and pull that. Could not get any response. Bah, there we go. Send this again. It's loading. And there we have it. Meanwhile, it has completed. So I was too slow. We could give this another try. Let's send this again. Copy this over there. I see it's running, so there we have it. It tells me it's currently running, and it's not done yet. But if I refresh, it should now tell me that it has now completed. So now it really has received all of the information that I want. All of the sources have been processed. That's exactly what we need. Right. So with that, let's switch gears a bit here. And the other thing that I want to achieve here today, I'm actually surprised that it's running like that. The other thing that I want to achieve is to read that registry and not mock that. So how would we do that? If we look a bit around on the internet, go in there, we're gonna need a binding. So we want to bind an Azure function to a Azure Storage Table. And have I already created that? Let me check. So there's the Storage Explorer, source registry. Yeah, I put it already in there. So here's a source registry. And I'm just gonna delete everything that we have in there. Yep. And add a new one. There we go. So this is what I want to map to that, to that DTO that I had in there. Let's switch back. What do we have in there? Find that. This has got a name. Oh, let's add that. Okay. Move this so that I could see this in the background. Probably can't. Get rid of these here. Add a property. Name. So that's going to be a string. So that would be our shortcut of the day. Add a property. Next, even Alt Tab does not work. There we go. Next one is a URL that we have in there. URL is also a string. That's going to be, I don't know, http://localhost. Whatever the thing it was, I don't remember. /API source. Doesn't really matter. We just want to verify that it's reading it. Add another one. Last update UTC. Does it support datetime? It does. There we go. Enter an ISO date time formatted string. What is an ISO datetime formatted string? I have no idea. 2019? 07? 20? Is that ISO formatted enough? No, it's not. No. Enter an ISO datetime formatted string. How would I form ISO date time formatted string? That's one. Why are you not happy with that? It's always these little things, right, that you're struggling with. ISO datetime formatted string. I don't know what you want from me. I have no idea. How hard can it be? Azure Storage Explorer, ISO datetime formatted string. Docs.microsoft.com. They would know, right? Isn't that exactly what I had? What do you want from me? Let's add another one. I'm gonna worry about that later. We need interval seconds. In 32. I know, let's say this is every 10 minutes, so that would be 600 seconds. Then we need is enabled. That's easy. Boolean. That's gonna be true. Isn't that fascinating? What would I enter there? What would that be? I can't believe this is something that I'm stuck with. Unable to create property datetime. Yep. Add milliseconds. You kidding me? Success! Add milliseconds. Obviously, you need milliseconds. So that's 2019, 7, 18. So let's make this today. I think that's, yeah, that's what our registry entry contains. So this is what I want to store in there. Our partition key is, do I need a partition key? I don't think I have to specify one, and I don't really have to worry with that small amount of data. My partition key is maybe I'm going to add something else later. Well, let's see, this is a registry entry. So that would then allow me to add another type in there later and filter by them. My row key is 1 for this one. Yep. I'm really glad it thinks that all these these values are null. What the heck just happened? Oh, there we go. I had to refresh. I was just wondering. Okay, so that's in there. Now, this is the data that I want to read. And like I said, before we got stuck in this datetime problem here, I want to know how to bind an Azure Storage Table binding to a function. So Azure Functions, they have this beautiful feature or concept called bindings. And there are input bindings and output bindings. So I can define that when a specific function is called, I want it to read, let's say, some data from an Azure blob storage. I just specify which blob it should read, and that could even be parameterized. So I could pass that parameter in the URL, and it will, right in the function, I will have that specific blob available. And something similar should be possible with storage tables. Now, in this case here, what I would like to see is that it doesn't bind a specific entry in there, because I want all of them. Instead, I want to bind the entire table, really. That's what we're after. So let's see. Azure Table Storage Bindings for Azure Functions. Sounds great. We are running on Functions 2.0. Who is still running Functions 1.0? Can we just retire that? Install the package. Nah. Read one entity. Bind to iQueryable? I don't know. Shows a C# function that reads multiple table rows. Derives from table entity. Okay, so I'm going to specify a table attribute here, and I tell it the name of the table and the partition that I'm reading. Great. I get back an iQueryable. Sounds awesome. And then I can iterate over it. Alternative input cloud table. iQueryable isn't supported in the Functions v2 runtime. I don't get that. So didn't up here, it's Functions 1 versus Functions 2, and down there they come up with an example of this is how you do it, but then the next paragraph says, but actually it's not working. Yay, well done. So what are we supposed to do then? Cloud table. I better read after this code snippet to see if there's another paragraph. Not that it says, by the way, cloud table isn't supported either. For more information, see get started with if you try to bind to and get an error message, make sure that you have a reference to the correct storage SDK. We shall try that. So at least it does not say that it's unsupported. So what do we have to do? We got to add a table, cloud table. I can do that. I can do that. Aggregator start. Where did they put it? After the trigger. I can put it wherever I want. Right there. What's my table called? Source registry. Source registry. Now I need to resolve that. How would I resolve that? Reference the correct storage SDK. Okay, let me see. Tell me more. Tell me more about the correct. Isn't this exactly the same page that I was just on? What is going on here? Install the package. Local development. Install the package. The package. In Visual, package man, install package. What am I supposed to install? Azure Web Jobs Extension Service Bus. Replace target version with a specific version such as 3.0.0 beta 5. Who wrote that? That doesn't make a lot of sense, does it? Install the correct version. Doesn't Visual Studio suggest anything if I just go control dot here? Using Microsoft Windows Azure.storage.table. Is that what they are using there? Microsoft Windows Azure.storage.table. That's cool. Let's do it. No, this one. Well, wait a second. I did that on the table, and now it fixed the cloud table. But what are you doing here? Table. Using data annotation schema. Okay, so we got the cloud table now. Apparently, it knew that one. And what is the other one? What am I missing? So if you wonder, I say like just install the package. I got burned once with those packages. So here's the thing: if you aren't careful, if you don't fully understand what NuGet packages contain what, there is a danger of things just not working. It builds, but then you get the strangest error messages. It's like, I expect this and that data type, but it's instead this and that data type, which is exactly the same, but they just live in different packages and different versions, and they're reorganized namespaces. And I don't know what, I had that in another project. So I want to fully understand, where do these things come from? What is table? So they've got web jobs host. Do I have those? I have web jobs host there. I've got Microsoft Azure web jobs. System. I don't get that. You see what I mean? There's nothing missing. Microsoft Azure Web Jobs. It's there. Microsoft Azure Web Jobs.host. I'm using that, but it's not even required. Logging. Storage table. Microsoft Windows Azure Storage Table. I got that one. System threading task. I see what I mean. This is the weird thing sometimes about these client libraries. The correct storage. Okay, what do they want me to install here? Microsoft Azure. I don't believe you. I don't believe you. Table attribute cloud table. Stack Overflow. It's always great if you end up on Stack Overflow. A full working example is here. Web jobs. Table attribute not found. Package Microsoft Azure Web Jobs extensions.storage. 301. Okay, let's give that a try. So this is important here. That says 301. That's the information that I was looking for, besides the package name. Manage NuGet packages. So let's see where we're at. Storage. 306. Let me go with 301. October 18. This depends on Azure Storage. You see, that is really the problem here. So this one depends on Azure Storage 931 and Azure Web Jobs 301. And the latest one, 931.301. That depends on... Heck, I just want to go with the latest. I don't want to have an old version, do I? It should work. I want it to work. Let's give it a try. Warren Buffett. I'm using assembly 305. You know, there's an update. I'm not worried that much about the attribute. I think I should have it now. So that, yeah, that solves it. It's there now. Let's just give it a try. I'm really worried about the whole thing not working in the end, but we'll see in a bit. Registry Entry. Is that the partition key I used? But that seems to be it. You're right. So where is that fully working example? What are they doing with it? Cloud table. Execute query segmented async. Oh, let's do that. Sounds good. So this is my registry table. I go registry table. I don't want a segmented query. Can I just execute a query? Oh, it's always segmented. Good. Good. My table is a table query. What is my tab entity? It was a registry entry, was it? What's the parameter? I promised to get better at pronouncing parameter. All right, there was something. So this had to be a table entity, right? I read that somewhere. I hope that resolves. Table entity. You happy now? It's happy. So we can execute a query here and then do what with it? For each item in query segment.result. That's just not okay to use result on an asynchronous method. Don't do it, just await it. So we want to go for each item in query segment. This is not a query segment, and that's my registry entries. That's what they really are, registry entries. And registry entries. I want to get rid of those here. Ah, that's what we're after here. Log information item. What? Cannot convert to string. Why not? Just trust me. Trust me, I'm an engineer. Okay, so let's see what happens. It should work, right? Maybe I'm just hoping I'm too careful here. But like I said, what was that about? That was, what did I try to read there? That was a binding to, it was a binding to a blob storage. And having a certain combination of packages, it would not work. So that's why I just went through this, trying to understand where are things coming from. Aggregator start. Let's call it. Hooray! I can't believe it. Indeed. It read something. And did we even get registry entries? Wow. How cool is that? Now let's try this. So this is working, which is awesome. Let's try this. I want to go ahead. You remember, here's this pending update. So should we be, yeah, only the brave ones, right? We want to try this. I want to update this, but I want to know exactly what it's doing before I do that. So let me go ahead and create a new branch, and we call this aggregator temp. Leave my bring my changes to aggregator. No, not really. So let's just verify. What do we have in here? You know what? I'm just gonna remember this here real quick. There's really no need to stash things. Now this is one of the things. That's why I say it just work. Let's try that. Let me update this here. I want to see if it's still working, because if I think about it, this is one of the things that I did in the previous project. I just updated to the latest version, and then hell broke loose. So let's see. Big question. If that still works, that would be amazing. So I also have this paragraph in mind, this warning. Make sure to add the right package, the right version. I should stop being so anxious about these things. It's working. Awesome. So we really have the latest and greatest NuGet packages in there. We can get the registry entries, and with those registry entries, we can remove these puppies here and pass them to the aggregator. That's cool. And I probably want to log here. Just go log information. It's all about logging. Registry entries. And found this here. So that should give us an idea what we're looking at. And oh, it's faster than expected. Bummer, what are we going to do now? Got almost half an hour left. Well, there is something that's been sitting in the back of my head since I started that, and that's how would I get the result values? So this is where this will be timer triggered. So it's going to run every, I don't know, 10 minutes. It's going to well, I don't need the return values. It's going to call this one here. This one here is going to wait for all of the tasks to complete. And then, what is it doing then? Well, it's going to write it. It's going to write the results into a database, right? That's what it's doing. That was the plan after all. So if I go over here, I always got to look at my diagram. So what was the plan? We want to output to a database, right? We want to write the results into a history table. Have I created that yet? That should be pretty empty. No data available in table. Good. So I want to write this in there, which makes me rethink my decision about using task.whenAll. Would I want to wait for all of the tasks to complete to write that data, or would I rather just write it whenever one of them is there? Because if one of them fails, I don't want all of them to be blocked or unavailable. That wouldn't make sense. Maybe I don't want to have a... I think what I really want is I want to write that result if one of them is available. But can I do this in here? So what I think what I want is this. I have this list of tasks which I create. I'm gonna add them there. And that's gonna kick all of them off. And then I wanna do something like this. I wanna have a while task completed. No, while there are tasks to process. While tasks dot count is greater than 0. Completed task equals tasks, no. Await task dot when any, right? When any of these tasks so if one of them completes, I'm gonna pick that. I'm gonna remove that from the list of tasks. Completed task, like that. And then what? Well, then to do write result to DB. I'm gonna remove it. And then this here, just return OK. Now, why am I hesitating, you may wonder? Maybe I'm overthinking that, but I learned about these durable functions that it's always going to restart this series. It's going to get into this orchestrator multiple times. Now, what if it comes here the first time and it finds 3 tasks, it runs them, it awaits the first one. So now my tasks list has got 3 entries. It awaits the first one, it removes it. And it comes in here the next time. And now it's again calling out that very same item. That's what I'm thinking about. It would again call all 3 of them. It would never finish. But then again, people working on this project are probably way smarter than I am. So let's just give it a try. Let's see what happens. We want to, or I want to put some logging in there. Can I have that? Can I get a logger, please? iLogger. I guess I can just add one, I think. So I want to go in here and say log information. Running aggregator. Processing. And we want to output how many of these we have. Registry entries dot count entries. Down here we say tasks left tasks.count. Let's just see. And I probably, no, I'm using the database already. Let me add something in here. That should be easy now. Can I duplicate that? Delete? No. Can add another one. That would have been too easy if we just kept all the data. Registry entry, but now I'm faster. Row key, that would be 2. Interval seconds, I don't really care, is enabled. Sure, last, oh god, not again. Oh, this is interesting. Now I don't have to enter anything. So it had to be an ISO format to date, and now it's just happy not having anything in there. Well, I'm not going to complain. HTTP, whatever. Insert. That's funny. Yeah, I think now the property just isn't there. Just doesn't see it. After all, it's a NoSQL storage. So now we've got 2 of them. We want to add a third one. Registry entry would be 3. 10. True. Name EV. HTTP example.com. Okay, so now I got 3. My mock data, those were 3 of them before. Okay, well, let's see what it's doing. And if you don't know anything about how is this working behind the scenes, you'd assume that it does work. So it probably does. So if that works, that would really be a milestone for today. Seven functions loaded. Move this over there. Okay, 70, 71. What are we getting? Sleeping? Yeah, I see it's never returning. Is it? Or did it? Processing 3 entries. I'm not exactly sure what it did. So where does this start? You know, now I could just say, well, it's working. That's all we wanted. But I'm always interested in this additional level of how is that possible? How did they make this happen? Because I think that's not a trivial problem to solve, this asynchronous behavior. Okay, executing aggregator. I'll make this wider here. You bet. Widescreen. There we go. Read registry entries and found. So this is in the... Okay, so that's down in this other method. Okay, so this is what we're passing. This array of entries is what we're passing to be executed. Then we are... The orchestrator is started. Okay, it says processing 3 entries. Sequence number. Yes, so that seems to be it. Is it running it 3 times in here? Scheduled. Reason aggregator. Scheduled. So sequence number 4, 5, 6. So it's scheduled it 3 times, which makes sense because we've got 3 sources. Now, tasks left. 3 method get, aggregator succeeded. Now it's running the aggregator again. Aggregator awaited. So that's different. So there it started and now it's awaited. I've got some identities. Now it's not scheduled, it's started. Good. So the first one returns after, or this one returns after 5 seconds, 3 seconds, 4 seconds, it seems. I don't fully understand it, but it seems to work. I think that's pretty fascinating. Because every time it encounters this here, it has to deserialize everything. But I guess it just stores which task has completed. So it doesn't matter if I recreate that, it probably associates somehow the name here and the item. It knows that this, it's exactly the same, so it's predictable what the result is going to be. And that's what's making it work. That's cool. So with that, we should be able to save that back to the database. That means this puppy here, the orchestrator, has to return. It has to get a table binding too. If I look at the, I ended it. So now if I look at the resulting URL, I would get back that string URL. So what I need is an output binding. How do I do that? Like I said, learning things here. So we need an Azure Storage Table output binding. This sounds promising here. Let's see what we have there. Use an Azure Table Storage output to write entities to a table in an Azure Storage account. Excellent, that's what we want. Note, this does not support updating existing. Use the table operation from the Azure. No, I don't want to do that. I just want to add something. Just keep on appending. Table storage. Return. Table, my table. And then I just return a history entry. Is it really that? Is that easy? Is it that easy? Well, we only know by trying. I'm so hesitant because it's a durable function and it's probably something completely different. But then again, it should just work. It shouldn't be a difference whether I'm in a regular function or in a durable function. Like I said, I'm overthinking that, but I'm always interested in the details, what's going on behind the scenes here. Why the heck does this work? Because that also helps me to understand if it's not working, what could be the reason. So we want to write to a history table and you see why this is tricky, because I said I wanted to write every completed source into the database. So here I'm waiting for the result. Maybe so when I'm here I would have all the results, but they should have been written already. So is it that this method should actually write it back into the database? Which brings up the question, why would I have to orchestrate this at all? Maybe I don't have to worry. Maybe I should just say schedule them all, run them, and you're done. Why even bother waiting for them? So we just fan out, but we don't fan in again. That's what I'm saying. But then again, I like it that it's all in here. Microsoft Auto Update just popped up. It's really not the best point in time to update my Windows now. So that's the completed task. Why don't we do that? Why don't we, what is this returning? Completed task. Call activity async. Oh, all right. So what I need here, I'm going to access completed task.result. Why is that not there? I'm lost. So I'm waiting for one of the tasks to complete. And what I get back here is a task. And oh, right, so this isn't just a task. This is a task of type source DTO, right? Yep, that's why. And now it has got a result property. Okay, so what we get back here is a source DTO. And it's okay to use completed task.result here because I know this one has been completed. So there's no danger of blocking synchronously here. Now change this to a var. So what I'm going to do here is I'm going to collect all of these. I want to have a list of source DTOs here. New list source DTO. And I'm going to add them in there. Source DTOs that add source DTO. And now what to do here, and then we remove this. Okay, and down here we are how do you do that? Return table history. Can I return an array? Shouldn't I just be able to now return source DTOs? No? What are you complaining about? Oh, okay, so this is then a list of source DTO. And we are returning this into the history table. Could it be that easy? It's again that question. It's always so hard to believe. Let's run it to find out. You know, the other day we had the discussion, but why would you want to do this anyway? Why would you bind input parameters and bind output parameters and have all these things? Why don't you just create a what's the client called? Cloud storage client instance, and then manually write that stuff back. It's all about chaining these things together, and that's what I like about it. So you don't have to worry about creating a client instance, and on top of that, the Azure Functions team, they probably know whether they should reuse a client or create a new one. So I kind of like those bindings. What's that? Table entity didn't. So apparently it did something because it complains, and I think I know the reason. So this source DTO that I have here, I can't write that back. Here's a bit of a bummer because it's not a table entity. So they must be table entities, but I don't feel like making this a table entity now. Is that a good idea? What's the consequence if I make that a table entity? I end up with a dependency on something that I don't want. Let me edit for now. Let's just see if this is working, and then we can think about mapping this to a separate type that we could write back. I should consider renaming those. Those names are confusing. Source DTO, text data DTO. I'm not even sure what this means. Table, where is this coming from? What are you complaining? I haven't written anything. Call stack. Table entity converter. DTOs.sourceDTO.object to iTable entity converter. Table entity must implement the property. I don't get it. I didn't implement that property over there, did I? I just made that a table entity and it was perfectly happy. Oh, no. Yes? What is a table entity? It's an iTable entity and it has got a row key. So what's... Why is it even executing that? You know, I haven't even called that method. I haven't called that function. What? Oh, it's looking at the list. That makes sense. Yeah, right. That's true. So that brings up an interesting question. Does it support that at all? Can I write multiple entities back? Or is that, because what they're doing here, they're returning one individual thing. You might, Poco. Do you know, looking at the chat window, if I can return an entire list of things here? What did I search for here? Azure Table Storage Output Binding List. Table binding, output binding, multiple rows. How do I update a row? Update a search. I don't think it's possible. Just gut feeling, but it's maybe one of these things to be researched. Output binding. What would I search for? Output binding. Table entity. Oh my god, entity. List of table entity. Update a row. Creating an upsert. No help from the chat either. So maybe we're not gonna solve that today. So this could be one of the things where, yeah, like I said, some research has to be done if this is supported. Queue trigger, Azure Storage Queue, no. Blob trigger. Where's table? Table output bindings. Connection, direction, in, out, binding. So that's for an individual one. Storage table. Table entity. Read multiple rows. Write one or more rows. The function runtimes provide. Are not used. iCollector. Okay. Read multiple table entities. Create table entities. That's interesting. iCollector, person table binding. That's what I'm supposed to use? Well, what about my return value here? Return table history. I'm just gonna give that a try. Now this is really something honestly, I don't really know exactly what I'm doing here. I'm just gonna change this back to a string. Put my OK back in here. And Let's add this. And that is a source DTO. How would it know where to write this to? Table binding. Table, okay. Table name. Collector. Table binding. Okay, so that's how you would specify it in the JSON file. I get that. But type table direction out. Where would I specify that? Function name. So I added. I mean, I could just bind this one here, right? That's probably what I'm after. Just that cloud table. But not this one, but just the history. And not really worry about output bindings. It's one of these things where I'm never clear. There are multiple ways of achieving this, and which one is the right one? Or does it matter? What is that here? Create. I'm getting really tired now. Add, create if not exists async, create async. Just want to put that in there. This one here. Create async, source DTO. And no need to store all of them. What do you want from me? Awaitable. Sure, go ahead, await it. And what else? Create async. Doesn't take one argument. Well, let's add another one. Table request options. No, table request options. I have no idea. I'm gonna call it a day here. It's getting too late. Ha! The message, looking at the chat window. Yeah. Good. I'm gonna stop here. If you have got an idea how to proceed from here, let me know. You can comment on the GitHub repo. Gonna put that out there again. So that's Krumlur/dashboard. Gonna put this in here again. Happy to hear from you. I'm just gonna put that in this temp branch now, and I'll probably continue on this tomorrow because, like I said, I feel like I'm a bit blocked here. I don't really know what I'm after here, what I'm trying to fix. So other branches. Why is there already an aggregator temp? I want to create a new one. Write to table in progress. New branch. Bring my changes to write to table in progress. Switch branch. Let's do that. Work in progress. Trying to get data back into storage table. Boom. Publish this puppy. Is publishing? Okay, so you can find that in this branch. I'll continue on that, and it's probably going to be solved by tomorrow. That's what happens always. As soon as I get up and return to the desk 5 minutes later, it occurs to me, hey, it would have been so simple. But right now I feel like I've been staring at this way too long and I need to take a break here. So all of you, thanks for watching, and I want to quickly see if there's some interesting channel currently online. Somebody's streaming, maybe somebody's doing programming. There was somebody doing, where is it? Somebody's making horror games. Why not? Game prototyping in Unity. I'm into game development. C#. Oh, that's French. Probably not gonna work. Nobody's doing any programming. What's going on here? This is game dev. Earthquake stream. What's going on with Ida? That looks good. So let's see what we have there. Ooh, paste. Yeah. You know, if you, is that only me? If you switch regularly between Windows and Mac, I'll never get the shortcut keys right. So it's Command there, Control over there, always the same thing. Again, I'll thank you for watching. I'm going to hand you over to this gentleman who's doing some coding there, doing some game development. I hope that's interesting. And I'm going to see you again next week, hopefully. Until then, bye.